Welcome to my ITCS 6160 Spring Semester 2025 Final Project Presentation. Implementing real-world use cases on a NoSQL database, specifically MongoDB, was the overall objective for the project. I outlined several bike rental company use cases for 5 different actors, including management, bike maintenance, marketing, bike transport, and the general public. These use cases leverage the City Bike sample bike trip dataset. The City Bike System dataset is a collection of 10,000 rental bike trips. As it details bike ride history, it mainly supports analytics use cases, which was the main focus of the queries for this project. From the sample document shown here, you can see the collection includes basic information about a rental bike ride, including starting and ending rental bike stations and the date time information. It also includes the bike identifier along with whether the rider was a subscriber or a pay-as-you-go customer. The document is pretty simple but does include embedded latitude and longitude coordinates for the starting and ending stations. In addition to MongoDB, the tools used to implement the project included VS Code with the MongoDB extension. This extension enables remote client connectivity to a MongoDB cluster for developing and executing queries within VS Code. For the dashboard portion of the project, I used MongoDB chart function included on the MongoDB Atlas. This visualization charts tool is good for quickly implementing dashboards on a MongoDB project. You can provide your own query or build a chart via a point-and-click user interface. I used both methods to provide a visualization for several of the project use cases. For the implementation phase of the project, 9 representative queries from the use case diagram were selected. The first is a management query returning the top and bottom station utilization and is a set of 4 aggregate queries. Queries 2 and 3 support bike maintenance, 1 nested query for monitoring bike utilization to determine when maintenance may be required, and 1 collection query for looking up the last end station for a bike so that it can be picked up for maintenance. Queries 4 through 3 on the slide support marketing, 1 collection query and 1 aggregate query that look at customer utilization. The third query leverages the bike station coordinates included in the trips collection to aggregate a count of rides that started or ended close to a specific location. Query 7 on the slide is a nested query for the bike transport actor to help determine what stations might require bike redistribution. And queries 8 and 9 on the slide are for the public actor, 1 to get a complete list of bike rental stations and 1 to find a list of bike stations in close proximity to their current location. Shown here is a screenshot of my project dashboard, which can be viewed on the web. The URL for the dashboard is included in my project report. On the upper left-hand side is a count of total bike trips. To the right of that are bar graphs showing the top and bottom start ride stations. To the right of that is a donut chart breaking down ride counts by age groups. The second row of the dashboard starts with bar graphs of the bottom and top 3 end ride stations, followed by a vertical bar graph showing bike utilization. And finally, another donut chart showing ride counts by hour of the day. As I'm relatively new to NoSQL databases, this project provided an opportunity to gain some experience by using MongoDB. I've noted here a few observations I've made from this experience. NoSQL databases provide data structure flexibility, especially suited for unstructured data. While it does have a programmer-friendly query syntax, my challenges in learning it would be even greater for a less technical business user. And as a cloud-deployed database platform, MongoDB comes with all the typical advantages and disadvantages that come with a cloud deployment. Thank you.